Welcome to another System2 video. On this video I'm going to talk about the panel controller that System2 has at its heart. I'm going to demonstrate the various features to you, including block occupancy and the various switch types that we can attach. This video very much builds on the previous one, which was the servo controller deep dive, so think of this in the same format and vein. Typically, you would fit this board into a Mimic panel, but that's not the only use case for this, and as we go through the video, we'll see where else it might be deployed. So if we start with the panel controller itself, we have the usual System2 connector here with 12 volts on the top two cables, 12 volts regulated power. This board needs a minimum of half an amp, and the connection for power is polarity independent. Then we've got the CAN H and the CAN L, or the two wires to the CAN network. We have the output ports to the LEDs on the top, and each port can drive a pair of LEDs such as these. And we supply the LEDs pre-wired, so you just plug them in. It's like a servo plug, and there you go. I've got a pair of LEDs hooked up on a channel. At the bottom we have the 16 inputs, and these would be push to make buttons generally, though you can use toggle switches, and you can also use point position indicators, and as you'll see later, block detectors as well. We have the only button on the board, which is the hotspot button, and this will start the hotspot if you're going to manually configure the Wi-Fi for the board. But if you've already done that elsewhere on your network, when you connect it, you can automatically send the Wi-Fi credentials to it. We're running a dual core processor here, and we've got the embedded Wi-Fi. The chip also has Bluetooth, but we've chosen not to enable it at this point. And the little black strip here is the antenna, which you should keep all of your cables clear of that really for best performance. Last, we have the pins for the termination jumper here. If it's a starter kit, they're usually fitted to the driver boards. You fit one at each end and that's it. You would leave the rest clear. As mentioned before, the board measures 8 by 10 centimeters, and there are 16 pairs of LED outputs for a total of 32, and there are 16 inputs on a panel controller. If we look at the configuration screen for the panel controller, we've got the input ports on the left, and on the right the output ports column. The input ports is probably the most amount of detail here. So first of all, we've got the location where I've entered left side of test bench. You can enter whatever you like. B for fiddle, wired, entrance. And if I save that, then this board will always have that pop up to tell me where it is. Useful tool. So we've got the physical ports here, 1 to 16, and these match the 16 inputs along the bottom of the panel controller here. The default is that the button type is a push to make, and I've attached 8 of those buttons to this. So if I press a button, you can see that something is flashing and then it moves and flashes back. Instead of individual LEDs on the top, I've attached a test panel because it's just easier to see 32 lights displayed up rather than me trying to hold pieces of LED like this. So if I attach or press the button to number 1, we can see channel 1 is working here, and somewhere else there'll be something moving, probably a servo controller, to give me the flash and then stop. So under the V-port column, we can enter a V-port in the range of 1 to 60,000. The defaults are usually fine, so this is configured as a board 1A, or number 1 I guess, yep, and it's going from 1 to 16. Now we still have the easy config on the panel controller, so if I was to select board number 2 for example, then where 1 finishes at 16, 2 would start at 17, and so on. So it makes it much easier to add boards if you take a default configuration. It doesn't just change the V-port on the input, but it also changes the V-port on the output to match. The different types of input that you can attach to these inputs include a push to make button, which we have here. You could attach a toggle switch, and with the toggle switch it basically would move over and then stay there until you release it. So I've now attached a toggle switch onto physical port number 8, and on the configuration screen I've set that to be a toggle switch. So now when I flick the switch I get some movement, and then I flick it and I get it and it comes back. So my panel is now operating with a mixture of toggle switches, and because the switch type can be selected from the menu on a port by port basis, you're free to mix up buttons as it suits you. So now I've introduced a second panel controller to the mix. The first one is, for example, behaving as a mimic panel with LED outputs and buttons attached. And we also have some spare unused connectors here. Let's move this out of the way. And I might want to use these for occupancy detection. So what I'll do is I will attach a block detector to channel number 16. I'll attach this here. Obviously I'm going to be running out of space, it's going to be rather tight, and I'll attach these cables to the feed, and the other ends I'll attach to the track. So I've now wired the block detector in series with the track supply, and I've connected it to channel 16. So on the second block detector I'm going to configure that to look at channel 16 and report the status. So I'm using this as a block detector and I'm going to report it on this board here. So what I need to do is tell the board that I'm using a occupancy sensor, and it's going to communicate automatically on VPort 16 on this panel controller, and the second panel controller, the default is port 16, so we are good to go there. So let's get some DCC power and let's see if we can detect some blocks. And there we go, I put my fingers on the track. Whoops, helps if you can see it. I put my fingers on the track and you can see that this is reading and then it drops down. So I hope you can see now I've a block detector here connected directly into the switch input, and I've told it that I want this configured as an occupancy sensor here. So when I put my fingers on the track or a loco or rolling stock, you can see the panel light changes here. If you have a toggle switch attached to a panel and you wish to invert the logic, in this case, for example, I have two boards displaying the output of this switch or input on channel number 8, one local and one remote. If I want to reverse the logic, then I have a number of options. If we imagine, for example, the switch is in the lower position, but the light is in the upper position, if I then wish to reverse that, what I can do is I can go onto the administration page for the panel controller and I can invert the input or the logic. And because this is an event-driven system, at the next event it will synchronize, and now I have the panels moving the opposite way. So when the switch is up, the high light is on. When the switch is down, the low light is on. Let's turn that off and resynchronize. Maybe I have the desire to reverse the output logic instead of the input logic. Say I want this panel, because it has a different LED configuration, I want that to be the opposite of this. So I can, as I'm on this panel's admin page, I'll just invert the output here on channel number 8. And now that's fallen down. So now each panel is displaying the opposite. So you can appreciate there's quite a lot of flexibility built into this system, and you have a lot of options on how you may choose to use it. If, for example, you have a point position indicator wired up instead of a block detector, that would be one of these little guys. It might be that your points are showing as turned, so they're being shown as turned instead of straight. And this would be a great way to invert the logic so that you can make it read correct for your layout without having to rewire it. On the previous video, we talked about servo controllers or servo drivers having the option to operate on a trigger V-port and a feedback V-port. The default is the feedback V-port, where you get this flashing light as the servo is moving. But if I now change the panel onto the trigger V-port, we'll take the flashing away. So I'll set the V-port for 321, which is the default for this, and now we'll have this guy flashing and this guy is just showing where the servo is. The eagle-eyed amongst you might be wondering, what's this latch column for? And why does it keep changing when I change the button type? Okay, let's address this column now. It's quite a powerful feature on the board. What this refers to is the time the switch contacts are held together. So on a switch, if you could imagine, they will come together and close the contact and then open. And we use this for a couple of things. First of all, we use it to debounce the button. If you can imagine the switch contacts opening and closing, or coming to close or going to open, because we read the switch about 1,000 times a second, during the opening and closing, it's possible with arcing that it may, generate a lot of data on the network as it goes open, close, and it's constantly changing the state until the contacts are separated. So what we do with the latch time is we latch closed, which means that there will be 100 millisecond gap between the first time those contacts close before they're read again. And this also means that if you separate them, it won't be acted on until that latch time has passed. And the defaults for this, for a toggle switch, we set them to 100 milliseconds. Push to make buttons, 400 milliseconds. And then for an occupancy sensor, it would be 800. And the reason for that is if you have an occupancy sensor on a piece of track and your track is dirty, so you may have dust on the track or dirty wheels, you can imagine that switch would be constantly going on and off and on and off and on and off. And if we were to send that data on the network, it would just flood it with garbage. So what we do is we latch it on, and then even if your wheels make contact every half second, it will show that the block is occupied as long as it's had a positive latch within that time period. So it's a way of cleaning up information that flows on the network and only presenting you with what is correct. So here's the push to make button. When I press it, the servo moves on the servo driver here. Here's a servo driver with 8 servos, and this one is attached to channel 1. And you can see this is moving end to end. Right, I'm going to show you now how we can abuse this column to our benefit. So if I tell it is a toggle switch, no, I'll tell you what, let's go for a track detector. And the track detector is just a current sensing device on the track that will sense when it's occupied. And it's similar to this switch. I can demonstrate it. So if I go down, it moves. And when I release it, after the timeout, which is 800 milliseconds, almost a second, it's 8/10 of a second. So if I just click it, it's held on and then it goes back. So if I change this timer, let's make it 2000 milliseconds or 2 seconds. When I press this or occupy a track or operate a switch somewhere, it will now hold its position for 2 seconds before releasing. So knowing this, say I have a section of track where when I enter it, I want a timed event to run, then I could say, okay, let's set this for 6 seconds, 6000. And so I enter a piece of track, I hit the switch, the servo's moved, it'll count to 6000 milliseconds or 6 seconds, and then it'll go back. So we can now automate some things on our layout by setting timers. And on this field, you can go up to 60 seconds. 60,000. I don't think I can do 60,001. No, 60,000. So now I press this and it's going to stay there for a minute. Don't want to wait a minute, so let's change it to 10 seconds and it goes back. On, count to 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see this indicator light is always correct. And you've seen how we could reverse that, reverse the logic, reverse the output of this, and so on. So there's quite a lot of power in here. And because you can mix up all these different switch and sensor types, you could have quite an interesting combination of effects on your layout. Okay, let's talk about the RGB, the red, green, blue data or color information that we can set up on this panel. Now, we don't yet have an RGB driver board, so we don't have the other end of this, but we've coded it on the panel and you can see it working. First of all, let me reset the board to its default values. So I've reset the board to its default values, save changes. And there we go, we've saved the changes. So let's talk about the color data that we're storing here. So on a normal input, it sends data out on the track, on the bus, and it tells a device that's configured to switch on, switch off, or whatever. If I set this to a occupancy sensor, then we can see that when it's set, something at the other end, an RGB LED or LED string, would react to that if the color data is present. So I could say to it here, set my data to red. And if I want that to be a foreground color, then whatever RGB is set at the receiving end, when this is occupied, it would show a red LED. If I have several points configured as, for example, a point position indicator because I wanted to enter or display a set route, I could set these and they would show white. And in this case, I would want them to be a background color. So when I, for example, set a point position sensor to indicate that it is turned, on that route for those LEDs connected to VPort whatever, 2 in this case, I want it to show that the route is set and I want it to be white. Then I can come along with an occupancy sensor set on a different VPort, and wherever this white is displayed, on top of that I could have a red color superimposed. So this will put the red on top of the white. I'll be demonstrating this in a later video when the product's ready, and you can see on the System2 web page the release schedule for that. You probably will have seen it on Pete Waterman's layout last year at Chester Cathedral, but the idea is you can set a background colour which would indicate a route selected, and you'll be able to indicate a foreground colour which primarily will indicate that a block is occupied. But you're free to have whatever colours you want. Make it yellow, set that to 0, now it's green, some kind of cyan and blue. Of course, this isn't limited to displaying roads on panels. You could put this lighting into buildings and all parts of your layout. So you could even have a timer that triggers, or when a train passes or a train enters or exits a tunnel, where the colour of the lighting changes to suit that mood. You could even have a timer that triggers an event so that you have the concept of time of day and night operating as well on a layout. There are tons of flexibilities, and we're only just beginning to discover what we can actually achieve with that. But more when we have the RGB driver ready. So now we'll talk about the output VPorts and their configuration, and in comparison this is going to be a relatively simple thing. We can change the VPort that each LED listens to, and we can choose whether we invert it or not. So on this button, if I press it, I have these two configured for viewport 1 and they're both responding and listening. If I want to invert this one, I can go to the panel controller, hit the invert button, and now it's displaying the opposite. Let's go back. If I want 4 of them to display that viewport, then 161, 161, 161. And now when I press the button, you can see all 4 are responding. So if I want the next 4 to indicate the trigger viewport, I can go 321, 321, 321, 321. And now I have these on the trigger and these on the feedback. Sorry, these on the feedback, these on the trigger, which means these should not flash. And there they go. So thanks for watching. I hope you can appreciate there's a lot of flexibility on the panel controller, and as we move to improve the product, we will be making software available for download for free. All you have to do is click the button and get the latest firmware. And we can see here, firmware is up to date and it was released on the 8th of January. Filming date is the 17th. But if we click on that, it's telling us latest software or firmware is installed. But if I look at the view entire history, I can see what changes have been rolled out on the release of the 8th of January, 13th of December, and so on. So thanks for watching. I'll see you in the next System 2 video.